please welcome everybody to this conversation about how to establish environmental product criteria for rock materials. It's a product that is headed by Skanska, and Malin Noreen, the product manager, will shortly introduce the product. She just joined, and I hope it works for her this time. In this group, we have, it's financed by SBUF, Svensk Byggindustri's Utvecklingsfond, and we have contracted Mark Elot, who is our author and our expert that is leading the work, who works at Shamakta. And then I, at the Massbalance, I'm helping out in a few minor roles as this moderator for this meeting. I was also the initiator for the last, the previous product that we had about measuring the content of our products today. So last year we did a larger study about 40 quarries in Sweden and Norway, where we measured the total content when it comes to arsenic and other heavy metals, and also the leaching criteria, leaching from those ones, both when it comes to the shake test and to column test. That was batch test and column test we done last year. So you can find that links for those studies in our discussion materials. And today, in this product that Mark is then heading under the guidance of Skanska, is about creating environmental product criteria, a risk model for this, and that's what the topic is for this meeting. In this meeting, this is kind of a Nordic outlook, and we would like then to, of course, invite our colleagues in our other countries, and we are very pleased to have kind of a dream team when it comes to risk assessment. We have Jussi Rainikainen from Paris to Psyche, the environmental institute in what we call it in Sweden, and the environmental agency. And we have Timo from GTK, in Sweden we call it SGU and or equivalent in Norway and Denmark. And then we have Gudny from Norway working at NGI, the Geological Institute there. And we have also Ole Hjelmer, who is from the Danish Waste Solution Company, but he is very famous for driving the European end of waste efforts in the early 21st century, 2005 to 2013 or something like that. So we are very pleased to have a great team that will guide us through this day, and they will also do some introductory presentations about how they view this topic. So here is the questions that we sent out, and then of course the conversation is open and we can direct it in the way that we please. But it is to establish a risk assessment model for a specific product. Rock material is what we are aiming for, but other products could be beneficial to discuss if there are, like we have experiences from other ones that could then help us when it comes to rock materials. And also to investigate and define the specific product, the use case, the characteristics, etc. And of course, after that, we have other questions that could be interesting, such as the longevity, end of life of road. And we also have, of course, the placement of those roads when we have a common recipient. And also, of course, what happens when disaster strikes, when we have a mud disaster like we had on the west coast in Sweden. So we will start with Mark and Malin, who will do the first presentation. And then we follow this list when it comes to the answer. And we are, I think, open to questions and remarks and comments during the whole conversation. So if something is unknown, please bring it up at once, so you don't sit and wonder that you don't understand something. So Mark, I think you can start. I think Malin is hopefully joining us later on. So I will change to your presentation. And that is here. And then from the beginning. Please, Mark, and please introduce yourself as well. I haven't done that properly. Your microphone, please.
Yes, I'm Mark Ellet from Shamakta, and I think I have met most of you, at least on this Zoom thing. And I work at Shamakta, and I'm trying to kind of do the hard work, developing the model and the values here together with also with my help from my colleague Karin Norrfors, who is also been working with this type of questions before. A few words about the project, because Malin is not yet in.
No, Malin is, I think she just told me that if we can do it instead, that would be great. Would you like to do that, Mark?
Yes. A little bit background. Approximately 100 million tons of aggregate products are produced in Sweden annually. And it's of course important that the use of these products would not give negative effects for human health or the environment. Unfortunately, there is lack of a generally accepted model or method for assessing the risk of using these types of material. But we know that this is a methodology which has been used in other areas, for example, in waste disposal, contaminated soils, which are similar, but they are not completely fully applicable directly to these kinds of things we are dealing with here. And as Carl mentioned, there has been a project testing various types of rock materials, which is, of course, a good basis for this project. We have tests from about 40 different types of rock materials. And from these tests, we have a broad analysis of concentrations and different kind of leaching tests which have been done. And we will intend to use that as a basis to see really how this material will act when it's used in constructions. So what we want to achieve is to develop an industry-wide environmental risk model that can then calculate risk using these aggregates products in various civil engineering aspects. The project, what we want to do is to have some uniform guidelines and levels for the environment risk assessment that can then be used by the industry and also, of course, accepted by the authorities. And we also want to develop a risk model, and that it should be connected to the methodology that exists today with declaring the safety and usability of construction product, for example, the CE marking and the performance declarations. So we're kind of heading for some kind of product that can be used as a product. You can take the next one. The project is divided into 7 work packages. And we have a time schedule which will last until a bit into 2024. And we have a reference groups which will have regular meetings, and there will also be preliminary reports at various instances. And we also have this project group who have regular meeting discussing the progress of the project. And going in a little bit more on the content of the various working packages, you can take the next slide, Carl. The first working package is basically what we're doing now. It's an evaluation of the existing methods which are available for risk assessment, kind of describing the current status based on literature studies, interviews, and a workshop like this. And what we're interested in is methods for risk assessments of various types of materials in structures, models for how chemical substances are leached and dispersed, and also various how different material properties can affect this spread. For example, there is many of these rock materials are rather large pieces of rock. It's not like a soil with a very fine-grained material, but it's more, and those things we believe can be important to look into in doing this model. And what we want to do is to find some basis for selecting this the most appropriate method for our purposes, and something which is kind of complicated enough to answer our questions, but not too complicated. And of course, we know from before that a lot of work of this has been done in the Nordic countries, and that's why you are invited here. And you have been looking at various types of waste and in various types of ways. So I think we can have some valuable exchange of information here today. You can go to the next slide. Then, of course, we need a basis for this model and to look at how to really, in a broader sense, choose the methodology we want to use. And for example, what type of scenarios are we looking at? What type of materials, what type of constructions, what dimensions, how is water dealt with in these constructions, because that can be important pathways for transport of substances, and also what does the environment look like where this construction is placed. And of course, you could find a multitude of different scenarios, and we are of course not able to look at all of these, but we will kind of try to, since we are trying to develop guidelines which would cover a lot of situations, we will look for typically rather critical scenarios where you have large constructions, etc., and perhaps a little bit more sensitive environment. And this work has been going on. The next thing is then to develop a conceptual model that we want to use. And we want to take account, of course, into human health, but also soil environment, and of course, protection of groundwater and surface water. And look at different pollutant dispersion processes and exposure pathways. And I don't know, I cannot point, I guess.
No, sorry, I can please.
But this is a kind of a principal section where you have a road which is built up of rock material. You have people using the road, people are working with the road, constructing the road, repairing the road. You have 5 people living next by, which can, of course, to some extent be exposed. And you have also water penetrating into this road, going into the groundwater, or leading off by drainage to some kind of lake. And of course, this groundwater can be used as drinking water in a nearby house if they have a well. So this is kind of the basic picture and what we want to include in this. And what is also, of course, is the time scales you are looking at. You are looking at the entire phases. We are trying to look at the construction phase, the maintenance phase, and also look at the entire lifespan, and to some extent also take into consideration the kind of final destiny of this road. It might be removed or something might happen with it, which we need to include. You can take the next slide, please. And when we have this conceptual model, this has to be converted into some kind of calculation model. And there are, of course, a lot of models developed for risk assessment. And what we want to do is to have something which would relate to the risks which are connected to the total content of various substances in these rock materials. But we also want to take into account models which consider leaching. And the effects that can have on groundwater and surface water. And the choice and setup of this calculation model will be based on what we see, what we have in the conceptual model. And for the total content, we are working with some hypothesis to use the same methodology, perhaps not all the exposure pathways or the same parameters, but the basic structure, what is used in the Swedish Environmental Protection Agency's guideline model, model for guidelines for contaminated soils. And then we need to develop, according to that, a leaching model, taking into consideration time-dependent leaching, transport, and dilution, which is kind of more advanced than what is used in the Swedish EPA guideline model. How is I with time, Carl?
You are fine.
I'm fine, okay. So we need a lot of data. We need data on the rock material, where we have this information from this Berg material test project. We need information about the construction, where Skanska has a lot of experience in building constructions like this and knows exactly the different dimensions and what type of materials are used in different places in these constructions. We need something which is deals with the conditions for leaching and the conditions for spreading of these substances. So we need to make some typical scenarios with groundwater levels and groundwater flows, etc. And we also have to know something about what we want to protect, what is the relevant type of objects that needs to be protected. For example, people living by or the groundwater and surface water. And then in order to kind of base these calculations, we also need to find some criteria for what effects are acceptable for human health, groundwater, soil, and surface water. And there are, of course, is a lot of information about that already. So this is the basic update. And what we have done so far is we have been looking at 4 different designs. One is wider, what we in Sweden call the 2+1 road. That is a road with changing the 2-lane roads for overtaking lanes, where you have a paved surface and you have assumed a stretch of 2,500 meter and a width of 16 meter and some thickness. We also have a larger impervious surface with asphalt covered, more or less impervious. We also have the same size of a surface, but then with a gravel surface. And also we have been looking at what happens if you have a stockpile of material, but so you have the same area covered, but with a greater thickness. And the idea is to all of these have the same area. So we are basically looking at what the other parameters would affect. And so far we have been using the Swedish, what I call here the TAC MRR model. MRR is what we in Sweden is basically, it's what levels constitute a negligible risk. And this is the model which has been used to calculate the leaching values for that. It's rather simple and it's rather conservative, but it's easy to use. So it gives some idea of where we will end up and what things are important. So what we have done is change the dimensions used in that and change a little bit the infiltration rates because we have paved surfaces. We have also made some changes in the flow in the surface water recipient. But basically the other parameters are the same as in the calculation of these MRR values. But one should remember that it's very conservative. For example, it assumes that you would have protection of the groundwater directly in contact or directly bordering the construction. You would basically put your groundwater well for drinking water just on this roadside, which is probably not a good idea. And it also assumes a very rapid mixing in the soil layer in the construction. And it also has parameters for leaching which are not adapted to the rock material. We have a lot of information to process from this bergmaterialstudie, which we have not yet done, which is gives some interesting information, and it seems that the leaching is not working exactly the same as is assumed in these type of soil leaching models. So it gives rather conservative values, especially for large areas. You can take the next slide. The model is rather simple. So basically, if you look on the pictures on the right-hand side, you have this grayish thing, which is then the rock material, and you have infiltration from the surface. And from there, it percolates down into the soil below the construction and reaches the groundwater. In this soil below the construction, it will be sorbed to the soil, and it will also be diluted. You have some mixing, and then it will then penetrate into the groundwater, and you would have a dilution with the groundwater flow coming upstreams. And you are looking at the what we call control points. The first one, EP1, is directly below the downstream of the construction. Is there you should uphold the criteria for groundwater, and then you have a EP2, which is in the surface water where you have further dilution, and there you should uphold the criteria for the surface water. And the next slide is the input data we have. I've shown you the dimensions before, but basically everything is the same. We have a density of the rock, which is usually higher than that of the soil material. The density of the soil is the density below the soil. And here we have a groundwater flow, an infiltration rate, which is for the paved surfaces, we assume 50 millimeters per year. For the graveled surface, we assumed 200 millimeters per year, and for this storage of rock material, we assumed 300 millimeters per year. And we also have a surface flow, rather small creek, which has a yearly flow of 1 million cubic meters per year. I think it's about 30 liters per second or something like that. So it's a rather small recipient we are looking at here. But as I said previously, these are just preliminary calculations. And you can take the next slide. And concerning, we're looking at the various types of heavy metals, and we are using the same KD values. That's the values determining the amount of sorption in the soil below this construction, and we are and that's the same values as has been used for calculating the Swedish MRR values, and also these kappa values, and this is a parameter that determines the rate of decline in the leaching. The whole thing is based that you have a leaching amount of leaching which would decline exponentially with time, and this parameter is used to calculate how fast this decline is. The lower the value, the slower the decline will be. The higher the value, the faster the decline will be. And then the various criteria used for groundwater and surface water.
So in this slide, you didn't use our figures. This is the European figures, isn't it? This is
yeah, and that is
landfill
actually
directive.
not this KD is not the KD of the rock material.
No.
It is the KD of the soil.
Got it.
But the kappa is not taken from the from the big study. So it might be more interesting to see that. And you can take the next slide. And this is some of the results we have got. And what it shows is the kind of maximum leaching allowed in order then to both protect the groundwater and the surface water. So we are looking at both in parallel, and the kind of most stringent criteria is then used as the total criteria. And it is the 4 cases we have studied: the road, the paved surface, the graveled surface, and the storage. And the last one is what is the value used for this negligible risk. And you can see that in most cases, you have higher guidelines for these types of materials, except perhaps for the storage, where you have quite a lot of rock. And of course, if you then assume that you have a well just at the side of this storage, it's not that surprising that you would have some kind of effect in that well, but it's of course not a realistic situation. You also see that there is quite a little, in many cases, the road gives higher values than the surfaces, depending a little bit of how the dilution comes from the road. There is quite a little small difference between the paved and the graveled surfaces, which is of course interesting. So this is just some preliminary calculations, and we will of course both look more into the data and look more also into the model, because I think that the model, assuming that you have the point of compliance directly downstream, for example, of a construction or a road or a surface, is not realistic. That you need you usually have some distance, even though it's perhaps not more than a few tens of meters. It has things we have studied have shown that has important effect on the results.
One thing I don't get here: what's the difference between the left and the right? What do we?
The left is the same, but I have it's removed these higher values. So the values which are dominating in the left picture, copper, chromium, and zinc, is removed. So it's the same, but in order to see the substances with lower values.
Now I understand it completely. Okay. Got it. Thank you.
So I think you can skip the next one. It's just a table. And then one of the benchmark is, of course, leaching tests are being more and more standard and are not extremely expensive anymore, and most labs do them, but they take still some time, and that you perhaps not have. And also, we believe that doing leaching tests on materials which have very low total content is kind of a waste of money and time. So the ambition is then to find, using these tests that have been done on soil material, to see if you can find some kind of criteria for when you would have a high risk that the leaching would be important. And if you exceed that criteria, you then perform the leaching test. But if you're below that criteria, you would kind of accept the usage of this without problems. So it's a way of simplifying the process. So, and of course, model and values are very nice to have, but you need to put them into a framework. And if you want to kind of make a product of this, you need also to prove and show to your customers that you're living to that. So in this last working package, we are looking at how to kind of present this in a good way, so that the users of the methodology and the producers of these rock materials can then easily use it in their business. And also you can also, of course, put some limitations on how to use it, because as you do with normal products, that you have can prescribe intended uses of these materials, which would kind of help to limit some of these more extreme possible use. So this is the basis, and I think the kind of outline of this project is very similar to other projects. So what we are looking, and perhaps would like to have your input on, is your experience of looking at conceptual models, types of structures and materials, and also what kind of scope you have in your calculations. Also, to what degree you kind of include different protections or actions for safety, which are, for example, done during construction or during maintenance of a road. Timescales you have been looking at, and also the problem that Carl mentioned previously, that usually these models, they look at one construction and one recipient, and you're kind of looking at how could that construction affect that recipient. A problem you have, especially with kind of structures with rock materials, is that you have not only one construction, you have many roads, you have many parking lots, etc., which affect the same recipient, and how to deal with that problem. And also how to deal with more extreme events. We have seen this summer that you can have examples of roads either being washed away by flooding or being removed by landslides, which is, of course, not something that you usually consider. But to some degree, I think you need to, even though it's not kind of a scenario you really use as a basis, but it's something you need to at least look into in this type of project. And also, of course, your experience with calculation models interesting, how you determine water flows in construction, leaching, etc. What we have found or seen so far from the leaching experiments with rock material is that doesn't seem to follow one single kind of exponential decline. If you look at the column experiments, there seems to be quite a large fraction which is leached rather fastly, but then the leaching reduces very quickly and goes to a much lower level. So we are thinking of perhaps having some kind of two-stage model or something like that. And also the transport, how that is done, what is reasonable ways of calculating and values for transport times for water, and also this KD value for the sorption in the soil, how to think about suitable recipients. And of course, we are of course also interested in any data you have where you have perhaps looked at leaching properties of different materials of different sizes, which is of course very important. We are doing some more experiments on that in the project here. And also in environment and criteria for recipients. And of course, when we come so far to the end, of course, it's look at the guidelines, how you have chosen to look at guidelines, looking at total concentrations compared to leachable concentrations. And it's also, of course, usual that you have this fantastic model which calculate values, but it's not uncommon that sometimes for different types of reasons, these values are adjusted before they are kind of put into print and made hard figures of. So this is kind of a little bit of the questions we have and the questions that we hope that we could have some input from you.
Great.
Thank you very much.
Thank you. So that is the first presentation, and anyone can jump in. We don't have any like assigned slots for conversations until the end of all those months, but if you have any questions that is now directly related to what Mark just told us, then you can of course post that question now by just shouting out or raising your hand. Next speaker is Jussi. So I will stop share here, and we welcome Jussi to the stage.
Thank you so much, and unfortunately I didn't send my presentation in advance, but I hope I can share my screen and then yes, show it myself. And I hope you don't mind if I switch off the camera, because I'm not.
No, that's
I'm
fine.
a bit worried that my connection is not stable enough, and I'm just showing my face here for everyone. So happy to be here and see you and hear you.
And please present yourself as well, because you are kind of a key person in this group. Of course, all five are, but we have been looking forward to the Finnish way of thinking. You are more advanced, you have more regulations and more guidelines than we have in Sweden. So please describe yourself. And
well, we can discuss that, but if that will indeed be the case. But just to ask, can you see now the full screen?
Yes, perfect.
Okay, perfect. So good to be here. Thanks for the invitation. So I'm mostly going to be talking about the Finnish regulated reuse of aggregates in Finland, and especially about the environmental criteria, mainly the leaching criteria that we have in Finland at the moment. So basically, I'm going to be talking mostly about the waste there on the ones on the left side, but these are the kind of regulations that we have in place at the moment for aggregates. First, there's this first regulation, so-called MARA decree. Some of you might know it from 2006. It covered crushed concrete and then fly ash and bottom ash from coal, wood, and peat combustion. And then we updated the regulation in 2017. And in addition to these two waste streams, it also includes these other other waste types mentioned there on the left. Then we have this MASA decree, which is about the soils from construction activities. Unfortunately, yet again, it's not finalized. So we've been working with this for years and years to come, and there's been all kinds of issues there. Well, I don't want to go into the details, otherwise I'm going to get so frustrated. But nevertheless, so that's supposed to be about these soils from construction sites, site remediation, and so forth. So basically, soils that have some kind of hazardous or potentially hazardous properties, mainly containing contaminants, containing waste materials, or containing acid sulfate minerals. And we kind of defined that, okay, you include all kinds of soil and rock materials, including stabilized soil, stretched sediments that will be reused on land, used gritting, sand, railer ballast, and so forth. And it also is about to include certain types of waste used for soil stabilization, either in situ or ex situ. And for example, like these Mara ashes, for example, that has been used for stabilization quite a lot. And then we also have this end of waste decree from last year, which is on given for us concrete, both unused concrete products and used concrete, but it's basically applies to facilities with environmental permits. So basically, this kind of demolition projects are excluded from that decree, but they are included in the Mara decree. So I'll start by telling something about this Mara leaching criteria. And the previous, the old criteria were based quite directly on the waste acceptance criteria for the inert waste landfill. And Ulla is here, so it's great. So he knows everything about this. So basically, I'll just briefly go through this. So those leaching limit values measured as in our case as LS ratio 10 were based on this modeling of this EU TAC working group, which Ule, I assume, was kind of responsible for, and using this kind of a numerical modeling approach. So first there's the modeling the source, the landfill and the leachate there, and then that's being transported into the unsaturated zone, and then to groundwater, and the first at the last stage there's this compliance point in groundwater, and the concentration there should then meet the quality standards for drinking water. And the final values we kind of calculated or partly adjusted upwards, mainly upwards based on political agreement. And as I mentioned, our criteria, the old ones, they were classified into two categories. So the first category was meant for constructions or applications with permeable cover, and those criteria were set directly based on the inert waste acceptance criteria for both of these waste streams. And the second category was for applications with the low permeability pavements such as asphalt. And for concrete, the same values once again were used, but they were then increased threefold for the ash. And of course, some other characteristics, characteristics of those constructions or applications, such as the dimensions, were not considered at all at that stage. So the same criteria applied to all sites. And of course, there were some other requirements in the decree. But the newer Mara decree, it had the same kind of starting point. So leaching from the waste, then the groundwater impact with high and low permeability cover. But in addition to groundwater, we also look at the impacts on surface water, and to some extent also soil was kind of considered there. And we had three different applications: road application, field, and kind of an embankment, such as a noise barrier, and also this kind of a specific as gravel road structure. And we defined the dimensions for each application and other parameters. And the cover materials were then kind of included in the water balances. There's also, we look at stabilization, but it's actually for the soil decree, not this Mara decree. And we kind of developed this, then I wanted to develop this modeling tool in Excel, so that it would be easy to use, quick to use, easy to understand, reproducibility of the modeling exercises also. And we also thought that, okay, this tool might then be used for case-specific assessments in environmental permit applications or projects like that. So we could give that other stakeholders. And the formulas and the parameters we based on literature review. And again, here I want to mention that the risk-based values, so the calculated values, they were not exactly the same as the final acceptance criteria, as Marco's actually referring to that in his presentation. And so these values, calculated values, they were partly adjusted downwards or upwards, considering mainly the leaching data from different waste materials that we had and got from the industry and other practitioners. And we also used this kind of an upper limit for the leaching, so maximum leaching, which was based on the non-hazardous waste landfill criteria. So that was kind of the, we didn't want to exceed that. And of course, there are also other requirements in the decree. For example, that specifically, it's not supposed to be applied in classified groundwater area. There are some safety distances from the wells and surface waters and so forth. But I've been talking about the criteria now, mainly the leaching criteria. So steps of the stages of the calculation, there are a lot of similarities between the EU TAC landfill acceptance criteria calculations, so using the same concepts and approaches mainly, and assuming equilibrium conditions. So first, coming up with this initial concentration using these EU kappa values, the updated ones from the Netherlands, and then deriving this the concentration reduction in relation to these maximum concentrations in the seepage, so the at the bottom of the Vado zone, and also in the groundwater. And we considered the source was kind of like a diminishing or shrinking source, but we didn't use the kappa value there when we were modeling the source, but we wanted to be a bit more conservative, so we used this based on this kind of a mass balance approach. And the seepage flow velocity in the Vado zone was based on annual infiltration, so very simple kind of a way of describing the situation. And the concentration at the bottom of the Vado zone was calculated based on this kind of an Ogata-Banks sort of a time-dependent equation. And the attenuation factors that we considered were dispersion, retardation, and biodegradation for some of the organic contaminants, both in the Vado zone and the aquifer. And there's also the dilution factor, so mixing of the seepage in groundwater, and also down gradient of the application. There's new infiltration before the point of compliance, so there's new mixing there as well. And the time period that we consider was 1,000 years, and you can the peak concentrations depending on the contaminants from half a year to almost 8,000 years. They kind of were calculated to occur. And you see on the right-hand side, you can see the kind of the model of the straw, also how the concentrations decline within the migration route. Then the third stage was estimating the maximum initial concentration at the source that corresponds the reference value at the point of compliance. So taking into account the attenuation, taking into account also both groundwater and surface water receptors, and using drinking water standards as the reference concentrations for groundwater and environmental quality standards for surface water. And based on this calculation, so the surface water was critical receptor in our case only for copper and zinc. And then at the last stage, the leaching limit value was kind of back calculated to correspond the maximum initial concentration at the source. And here, once again, we use the updated EU kappa values and the approach as in the case of calculating the initial concentration. And we also needed to use some kind of iteration at this point to achieve this stable value for this diminishing source due to some of the constraints in this deterministic Excel-based modeling approach. So there's kind of a direct solution for this analytical solution. So had some constraints. And this is just quickly just to say that, okay, these kind of conceptual models we used, this is an example from the road application, see more or less all the parameters that were considered, and then coming up with the final value for the leached. These are the values. You can see there. I think the red ones are describing kind of the upper limits. So the risk values would have been higher, and I have to say that, okay, there was attenuation evaluated in the beta zone and in the groundwater, but the dilution, in this very simple kind of approach, the dilution in the groundwater actually is the main factor in the concentration reduction. Of course, the beta zone attenuation also has some effects and others. But if we look at, for example, this type of narrow applications, such as the roads, there's, well, high dilution. We were considering kind of like the flow rate perpendicular to the structure, and the point of compliance was at the plume center line. So also we only didn't take the dispersion, lateral dispersion, for example, into account. So high dilution for narrow applications and therefore rather high limits. On the other hand, wide applications such as these fields type of applications, parking lots, whatever, 100 times 100 meters was the surface area. Low dilution, low limit, and then thick applications, so lots of contaminant mass, meaning rather long-term source. I would say moderately low limit. And also, we kind of thought that, okay, this we got some criticism for this approach, and I know that it's by no means perfect. I'm not really advocating for you guys this approach, but we just we had our reasons to do it this way. But still, we wanted to make sure or try to find out whether these kind of rather simple deterministic modeling approaches can do the trick. So we were comparing our results with these EU TAC landfill acceptance criteria calculations. Of course, the approaches are not all the parameters could be made similar because the approaches are different, but as long as that was possible, we try to do that. And if we, for example, look at that option where there's the rather low groundwater flow conditions and the thin beta shown, and then we compare the results, you can see that the greatest difference between those results was twofold, and for many contaminants, basically you get the same result, even though that was totally different modeling approach and numerical modeling and so forth. So I would say that I based on that comparison, that this kind of approach at least might do the trick. Whether it is realistic or not, well, that's another question. Then quickly about the soil decree, which really is a draft yet. We have been thinking about using the same leaching limits as for the Maraways I just showed you, but including here the values for the stabilized soils or dredged sediments. And of course, with the stabilization, you have a lower infiltration, and it means that the risk-based values actually, due to the time-dependent migration, got really high, not reaching the point of compliance necessarily at the time period we were looking at. So mostly those values are based on the so-called the upper limits, so the non-hazardous waste landfill criteria. And these leaching tests, we have been thinking that, okay, as we kind of try to do some of the diffuse tests, and it's very difficult to interpret the results and it takes time. So I think it's probably a bit more practical to use the same type of batch or the column tests, but then of course you have to do these kind of pre-stabilization tests first, and then take the cross the sample and then do the leaching test. But nevertheless, this leaching test is to be done from the stabilized soil and sediment, not from the waste, as in the case of the Mara decree. We're also going to be issuing these total concentrations, likely based on our soil guideline values, which are given in another regulation, but those will be updated in 2020. And of course, there are also a lot of other requirements in that decree as well. For example, required multi-increment sampling, first defining the soil batch to be reused, maximum limit or amount for that, then taking at least 50 increments per sample, and having a defined protocol also for the sample pre-treatment and so forth. But we also try to include a possibility for site-specific risk assessment within the decree in cases where these above mentioned criteria will be exceeded, so that it would to make it more flexible, reasonable in some cases. Just shortly about the waste leaching criteria for the crushed concrete. Once again, we were using the same procedure than for this MARA decree, but here assessing only the leachate or the pore water concentration at the source to be conservative enough. And we had lots of discussions, and some people would have, well, let's not go into that, but nevertheless, trying to come up with a rather conservative approach here. So first, estimating the maximum leachate or pore water concentration at the source that corresponds to the reference value, which again we used, that was the drinking water standard, and then again back calculating the leaching limit value that corresponds to that maximum leachate concentrations. And again, these calculated values, they were not the same as the final values, and they were adjusted again both downwards and upwards, considering once again the leaching data that we got from these crushed concrete samples, and there were quite a lot of them delivered by the industry. And based on that data set, most results, I think it's something like 85% and more, complied with these criteria based on that data. But now, after people have been applying it, some people are complaining that these values are too low. But then again, I don't know if they gave us wrong results then. So should have been honest with us in the first
Exactly.
If you look at, for example, just out of curiosity, for example, the criteria for chromium and molybdenum, they are higher than the most stringent MARA values, which is the decree. But as we looked at the data, it turned out that the leaching from, let's say, typical cement, so it's a natural ingredient, so that the leaching from typical cement confirmed to be kind of naturally high for chromium and molybdenum. But there are justifications. That's why to increase them. And of course, there's also other requirements for quality assurance and so forth. That regulation also. And as my final slide, I just wanted to give some generic requirements I think that we need in order to move into the circular economy, especially in terms of the reuse of aggregates and waste materials. So first, what I think that is really needed is setting clear policy goals on a national basis or regional basis or whatever. So there really needs to be this political will, I would say, because so that all the even the authorities have to kind of understand the benefits of this. And if you first set the goals, of course, then you have to manage the transition from the traditional linear economy to the circular one, and then moving from these policy objectives to these kind of targeted measures, the proper implementation, whether it's increasing knowledge, doing research, education, training, doing demonstrations, whatever is needed. Of course, the regulatory basis needs to be valid for the task, actually supporting this, not only restricting it, and also on the industry side and practitioners side, improving and developing technical expertise and facilities, whether it's on treatment of these soil materials or waste materials, logistic measures, all kinds of tools, including risk assessment tools and so forth. And third, but not least, I would say that we really and always should try to foster trust and commitment between different stakeholders. So open cross-sectional dialogue between authorities, industries, and other stakeholders all along, and trying to ensure that whatever you do, it will be transparent and you always have the high level of quality insurance included. And although today we are talking about risk-based approaches, I would say that justified risk-based approaches, models, tools are really needed, but it's not only about the risk. So we also would like to see that they are setting the bar high enough also for these operative and regulative practices, also trying to foster this technological innovation and development when it comes, for example, to waste treatment is something to keep in mind. And actions most definitely are needed on all the levels of decision making and from all the stakeholders. So that's my very quick.
That's great. That's great, Jussi. I'm very pleased for that presentation. It was like a breeze. You speak even faster than I do, so that's great.
I haven't been talking about this stuff, not even in Finnish, in Finnish and certainly not in English for years and years, so I
Well,
might have struggled a bit, but hopefully you got at least some ideas.
You succeeded greatly in this presentation.
Perfect.
It was great, awesome.
Perfect.
So I think we should continue logical and let Timo continue and doing the next step. Timo, welcome to the stage, and please introduce yourself. You are.
Thank you.
I saw once on the website. It was the Timo on the website of GTK. So you are quite the man in GTK. Welcome.
Oh, that's surprising. Thank you for inviting us. And I'm Timo Tarvainen, senior scientist from Geological Survey of Finland, GTK. Since 1986, working for GTK, some experience from that, many different kinds of projects. And I picked up some additional projects we have been carried out partly together with Jussi's Institute. When Jussi gave you better direct input to your project, I might give you some additional ideas.
Surely you will.
Would you like me to share the screen?
Yeah, share you. That's probably easier if you can.
Yes.
So share screen at the bottom, and then because then you can adjust speed to your liking.
Yes. Share screen and
then you have to
screen
click on that and then share again to click twice. And if it doesn't work.
Okay, still press share.
Yes,
okay.
Now we go. Yes, perfect.
Yes. And now we go to slide number 1, projects and databases, some pickups from work of Geological Survey of Finland. And we start with ASROX. It was a life-funded project about 10 years ago about guidelines for sustainable exploitation of aggregate resources in areas with elevated arsenic concentrations. So we are dealing with only one harmful element, arsenic, which is a very common problem in Finland. This was cooperation with Jussi's Institute, Finnish Environment Institute, and Tampere Technical University. Here you have still working web page, even in English one. And while your project is about using these aggregates in road construction or fields, something else, for ASROX, it was to provide guidelines and risk management tools for the industry, for the exploitation of natural aggregate resources in areas with naturally elevated arsenic concentrations.
Good.
So this was more dealing with how to work in the area where you are producing the aggregates. Mm-hmm. But we made some analysis, leaching test of aggregate products as well, and that could be useful for you. Our study areas was so-called Tampere Arsenic Province, southwest Finland, where we have naturally high arsenic concentration both in bedrock and in soils. Originally, we had 21 preliminary investigation sites, aggregate production sites where we used crushed bedrock. There were gravel sites, and then we have third kind of sites. We have construction sites where people were building a house or roads or something, and there was a short time aggregate production. Finally, we picked up 4 sites with highest arsenic concentration for detailed investigation. And as I told, the focus was on development of instruction for the producers. The highest arsenic concentrations were measured from those construction sites where you had short-time aggregate production. Because usually when you have a company who is producing aggregates, it selects rock type where you have big mass of technically good quality rock aggregate material. But when you are just using, making a road and make a road cut and use the same material somewhere else, you might end up of using a bit different rock type. In addition to aggregate products, we took samples from the rock itself before it was used, and this is our high technology sampling equipment, handheld drill and a paper plate, and that was very easy way to get samples from the rock.
Great.
So we selected some aggregate products which were analyzed in the laboratory. We analyzed semi-total concentrations using Aquaritia. We used weak leaches, ammonium acetate, and we had 3 kinds of leaching test. Stand-up collation test, then we had 2-stage batch test, and then there was a special test for chemical properties of aggregates, which was used 10 years ago. I don't know if anybody uses it anymore. And these results, if you go to our website, which was on the first folder, you can download the report of the leaching tests, but that's unfortunately only in Finnish. But if Mark wants to have, you can contact me and we can have a look together. So because that might be nice to compare with your results of leaching tests. Usually the concentration in leaching tests were low, but what we did, we also measured leaching in different pH values, and that makes a big difference. So for arsenic, if you have very low pH or higher pH than normal soil, the arsenic leaching comes up very big difference. So that might be some additional information for you. Aquaritia soluble arsenic, so semi-total concentration were 14 to 200 milligrams per kilogram, but what is leachable was only 1-2% of the total concentration. Okay, there were not so many samples as you had in your work. 10 years ago, we were thinking of CE marking and leaching tests, and we didn't develop any new specific classification for aggregate products based on arsenic concentrations, because according to construction production regulation, CE marking of an aggregate product should include information of technical properties and also dangerous substances. So the basic principle should be that those construction products from which dangerous substances might be released to soil or to groundwater or the surface should be tested. And 10 years ago, our colleagues from Tampere Technical University told that the European test methods for leaching are under validation, and some of the tests were very similar. We tested in ash rocks, but there were no national or European threshold values for the interpretation of leaching test results, and it might be that it's still valid 10 years later. Okay, that was the ash rocks project. Then I picked a totally different subject. We have soil geochemical baseline map server called Tapir at Geological Survey of Finland, originally also developed together with Jussi's Institute, Finnish Environment Institute. In Finland, geochemical baseline of soil is a combination of natural background concentration of metals in soil plus diffuse anthropogenic input, so atmospheric deposition or something like that on topsoil. We have a database which covers whole country. We have natural soils. We have 12 towns, so urban soils. We have focused on mining areas, about 90,000 samples. And when you use the map server, you show the place of your interest and you select the soil type, sandy soil, till soil, and Tapir looks for samples around your site and calculates baseline value for 18 metals. Today, the main reason to use this method is is the assessment of soil contamination and remediation needs. You need some kind of reference data. So we have the degree on assessment of soil contamination, and there are some threshold values, but if the local baseline is higher, you can forget the number which Jussi has written in the law text, so you can use the regional baseline instead. And what we see that when, as Jussi told in 2015, we will have the soil degree, which we have called MASA degree. Jussi might be clever enough to write there that you could consider the baseline values of the site where you are using these excavated materials in decision making. But what is the number? If the program finds 30 samples around your site of interest, you will have 30 different values for arsenic, or cadmium, or nickel, or zinc, or whatever. So what is the right value? Is it the maximum or mean value? We decided to read ISO standard 19258, and there was an appendix where they suggested to use this kind of mathematical tool, which is so simple that even I can calculate the values. I don't need Jussi for this. So it's based on 25th and 75th percentile. And if you are familiar with box whisker plots, it's the highest value the upper whisker line can reach. So it's basically the same as upper to K inner fence if you use mathematical terms. And this is used as the suggested maximum acceptable baseline concentration for your study area. So sometimes it's really the maximum value of the 30 analyses or 50 analyses, but in many cases it leaves out some outliers. And as I told, it can be used instead of the threshold value given in the degree of assessment of soil contamination and remediation needs if it's higher than the value in the degree. And then, because many of our cases, we have been studying arsenic a lot, antimony came into my mind because antimony behaves geochemically many times a bit like arsenic. You find antimony in the same areas. And we have learned from some other projects, studying old shooting ranges, and we had a project on dredged sediments from sea which were deposited on land, that antimony was the element which was more easy mobile than many other elements. So leaching tests gave higher results for antimony, so maybe you should have a closer look to antimony in sometimes. And I have heard that you have antimony in some aggregate products in Finland, but I don't know any details of that. So these were some ideas picked up from our work. We have an expert, Mika, I could give his information. He's really expert on aggregates in general, but I was invited here as a geochemist.
Yeah.
Thank you.
Thank you. We would love to speak to Mika, of course. Great presentation, Timo. Very, very interesting. And yes, the ASRock project is cool. And your tool, the Tapir one, is very impressive, at least compared to the Swedish one. I don't know exactly how it looks in Denmark and in Norway. So we thank you, and we will now continue to Norway and Gudny. We have met Gudny. We who have been in my circles or in our circles before, and I tried to meet, of course, Gudny. I flew to Norway, but then of course she was away on a more important meeting with more important people. But I'm very pleased to have you here in this meeting, Gudny. And I was very impressed by your ability to also get the Norwegian Environmental Protection Agency to agree to your research and do it together with them, financed by Miljödirektoratet, and that's very impressive. So welcome, and please present yourself.
Thank you, Carl, for the introduction. Do you see my screen?
Yes,
now?
perfect.
Fine. Well, my name is Gudny Okkenhaug, and I work at NGI, which is the Norwegian Geotechnical Institute, not Geological Institute. And I also have a part-time at NMBU, the university in Ås, 20% position. And the project I'm going to tell you a little bit about, that's some years ago. Well, it was in 2020. Together with SINTEF, we had a project for the Norwegian Environmental Authorities, Miljödirektoratet. And also partly financed by the stakeholders or the concrete stakeholders. One part of that work was also to do risk assessment, or using a risk assessment model for determination of accept criteria for chromium-6. And I also have added some other colleagues here, Katrine Ekbo, Sarah Hale, and Gijs Bredfeldt. They were actually the ones doing this work, so they should be accredited. Yes, so we'll try to move here. Do you see any changes here now?
Not yet? No, yes.
Yeah, no, yes. Yeah, so what was the goal? It was to create a foundation for establishing acceptance criteria for chromium-6 in concrete waste by conducting a comprehensive risk assessment focused on the leaching of chromium-6 in real-world recycling scenarios. So that was the agreement with the environmental authorities. And they were really an active part in this work. So we had our meetings, not often, but to discuss kind of decisions we were taking during the work. So, and it was based on a quite scientific way, because we started with to kind of gather all the material we knew about chromium-6 in concrete and leaching and how it behaves. And there were also quite a lot of data. We also had a quite comprehensive laboratory and field measurements, testing experiments. And then as the last work package, we did this modeling, the risk modeling, to establish guideline value. And these laboratory and field experiments, they were quite important. Also, I don't remember who it was, but someone mentioned that it's not only about calculating the risk, it's also to give trust to in this case, it was the environmental authorities, to also show that what we model is also what we maybe get in real life. So we took a lot of solid samples, leaching tests, both batch and column testing. We had several field tests, like this road subbase, which SINTEF had been following since 2004. So they had a lot of data on the leaching of concrete, or chromium, not chromium-6, but they continued in this project using or analyzing for chromium-6 also. And here they had used waste concrete as a part of the road. We had a parking lot, or we were kind of imitating a parking lot without asphalt. And we also had some container tests at Lindum landfill site. So there were several kind of user partners also part of this, contributing to test sites, which is was of course of great interest. So, but to know, just to focus on the risk assessment of chromium-6 in concrete. So the questions in this project, they were, could we use the spreading leaching model, which was developed for contaminated soil. Could we use this for the reuse or to derive a threshold value for the reuse of concrete? And which scenarios should we consider in this case? And could they be defined and simplified for our purposes? And what should be the guiding environmental objectives for evaluating this leaching to the environment? So what kind of, for example, limit values for surface water or groundwater? So these were questions we also discussed with the environmental authorities. So they had a very kind of open line to us. So what we used were it's a model developed for the environmental authorities by NGI, and it's developed for soil contaminant leaching, and it's also linked to the risk model. It's a simple box model where you have the contamination in the unsaturated zone. We take into account sorption, desorption, and degradation. So it's kind of a worst case scenario because it's kind of infiltrating direct into the groundwater. And in the groundwater, you have the transport to a recipient. And here you can also imagine that you have a groundwater well, for example. It's a limited source. So the source is kind of depleting. And so you will have kind of a top of concentration downwards this source. And it's simple, it's 1-2 dimensional, and we don't look at the surface runoff. So we don't include any surface contaminated surface runoff. So this, I think it looks very similar to the other models we have been looking at today. The reuse scenarios also discussed with the environmental authorities. We had this conceptual model, which you see here, also quite similar to other figures we have seen today. So we had the asphalt parking lot, which was kind of sealed cover. Class 2 was in a road substructure, so it's a reinforcement layer. Concrete used as a noise barrier, and concrete in a landfill, and that it's not a disposal, it's for utfyllning. Yeah. And the critical parameters in the model, they were, because in this here, it's not used a kappa value. It's KD value which is used. So it's in the leaching from concrete is not leaching from soil, so it's a little bit different, of course. But it's I would say more conservative because you're using KD values, which is quite low in this case. But this is, of course, something which could be maybe improved through like a kappa way of describing the leaching. So the KD values we used in our modeling was 330 and 300 liter per kilogram, where 30 was the one which is default in the model from the authorities when you use it for contaminated soil. And of course, the area and the thickness is quite critical in the reuse scenario. And here we thought, okay, we look at what is the kind of normal or very usual amount of concrete used in a reuse project. So that was 10,000 cubic meters. So we adapted this length and width and thickness to this amount. Precipitation, we have a lot of precipitation in also in Oslo at the moment, at least. So the infiltration factor is a very important critical parameter for leaching. Distance to the point where the environmental objective recipient, which is well or surface water. And we chose in this model the AAEQS from the Water Framework Directive, or the Norwegian value of 3 microgram chromium per liter. So that was the value which is not going to be, yeah, that's the maximum value we can admit. So this is, sorry for Norwegian here, but it's this parameter selections for the different classes. So as you see here, we are, yeah, here we see it more better. For asphalt, we use the factor of 0.2, which and also for concrete. For vegetation in this the noise barrier, it was a little bit higher. And for the landfill, we used a quite high one, which is 0.8. But this is also the one used by default in the model tool from the authorities when you use it for.
Mark,
Pardon?
question
Yeah.
from Mark.
I don't see
Yeah.
it.
Yeah, that's fine.
Yes,
Yep.
question. By infiltration factor, you mean that for the asphalt, 20% of the precipitation would infiltrate? Is
Yeah.
that correct?
That's
Okay.
correct. That's correct.
Okay.
Maybe that's high, but it's you know, you always try to be conservative, and maybe at the end you're too conservative. But I think you shouldn't expect that all your asphalt is 100% working.
No.
And also in future we will probably have more permeable asphalts too. The area 50 times 50, and for this road construction it's a more narrow and longer distance. And here the thickness is, if I compare to your number, Mark, it's much thicker compared to yours. And so, but as I said, it was 10,000 cubic meter of concrete, which should be kind of the same for all these scenarios. And if we sorry. So what kind of acceptable chromium concentration did we get? If you look at when you're using the default values for the different classes, we see that it's actually the road construction which gives the lowest value. And it has to be said that for the Norwegian, just a moment, I'm going in the wrong direction here. For the value, guideline value we have in Norway today, it's 8 milligram per kilogram. That's the solid phase, right? So this, what we have calculated here, is we've back calculated from the maximum allowed concentration in the recipient, which was not groundwater, it was a small river. Then we will get these values for these different scenarios. So we see for the road construction, this is lower than the current 8 milligram per kilogram using default values. But if we reduce the KD to 3, which is a very low KD value for chromium 6, but let's say that's an extreme situation, we see that it's all these 3 classes will be lower compared to the guideline, which I have to say that is the guideline for the free use of waste concrete in Norway. But if the distance is increasing to 3, or the KD is increasing, and also the distance to the recipient, the guideline value or the acceptance criteria are also increasing. So this work was done actually after the environmental authorities had launched the 8 milligram per kilogram. But we somehow this is very conservative, so it was kind of a frame result work for them. So still this was acceptable for the authorities. So they did not try to change this 8 milligram per kilogram due to this modeling work.
And this you used 30, which is the standard one, I presume, in the EU directive for waste, landfill waste. Why you didn't use any field values for that one? You didn't calculate the KD value, I mean.
Once more, Carl, what did you say?
The 30 is the KD value for chromium from the landfill directive, correct? It's not
it's not. No, it's the Norwegian tool, or in this modeling tool, you have default values for all also for KD values for all elements. And the 30 is taken from the default value, which is supposed to be conservative.
Very much
so. If you look to, for example, we also did the calculations of the values we took from our laboratory tests, and there we got up to like 2,000, 3,000 liters per kilogram.
That's what I'm talking about. That's what I found as well.
Yeah. And that was one of the reasons also that the authorities were kind of released that, okay, field tests, laboratory tests show quite different values here. So also in this case, the KD value of 300 would be kind of conservative. So assumption in the model, which was quite important to take or to kind of discuss also with the authorities, the unsaturated zone, because that's all the unsaturated zone consists of this material, which is leaching something, right? So this is on the one hand very conservative, but on the other hand, if compared to the case we discuss here with the rock samples or the rock material, you could kind of expect that maybe all the road will consist of this type of material. So maybe you should be so conservative that you're expecting that all your road will consist of the same rock material. We discussed this KD value, which is quite conservative, and maybe also not for concrete or for rock samples will not be. It's KD value, that's the distribution coefficient, so it's sorption, and in concrete sample or material, and also in rock samples, it's minerals dissolving, so it's different. But maybe the kappa value would be better in this case, also for chromium 6 in concrete. We had a limited water body, but I think that is that in our case that was okay. It's 0.16 cubic per second. I don't know if maybe it's in the same range as you have, Mark. It was realistic quantities of concrete for reuse. And yeah, as I said, it's due to the fact that we also had all these results from field and laboratory tests. It kind of indicated that the 8 milligram per kilogram chromium 6 in concrete is a acceptable level to use. I have one last one, which has nothing to do with the environmental authority project, but it's maybe interesting for you, because we have a cooperation with the Bærum Ressursbank, which is a large network, I would say, in Bærum, or owned by Bærum Kommune. We try to reuse surplus masses from infrastructure projects in the region, because they see that they have really a lot of material and surplus masses which should be better used or reused than just landfill. So this is kind of a test cooperation where we are testing the geochemical, or doing a geochemical characterization of 16 different rock samples from the it's mainly the Oslo region, from different infrastructure projects. And we do solid concentrations, different methods, and we also have the standard leaching test from the waste directive, batch and column test, and we are also testing out this horizontal dynamic surface leaching test. The second one, which is more like the monolithic test, because we thought that if you reuse surplus masses from these projects, it's more realistic that you have larger stones than smaller pieces. But we also do the same test, slightly modified with the smaller fractions, that is from 0 to 4 and 4 to 8 millimeter. So we will try to, we just got the results, so we have not analyzed it yet, but we will try to see the effect of surface area on the leaching. So this could maybe be interesting for your project too. So to be continued. Yeah.
The data is available from this Barum.
Yeah. So the what is now available is the batch and column test, the standard one, and the total. So, but the rest is still under under work, so to say, so that we can share with you.
Great. Thank you, Gudny. Great presentation. Very, very nice. So last but not least, we have Ole, who I started reading like 2-3 years ago, and he has published many reports of great importance for us. We are happy for him to be here. Please, Ole, introduce yourself and please take your and make your comments on what have been said today.
Well, thank you for inviting me. This has been extremely interesting to see these different and then maybe not so different approaches to risk assessment, and I hope I can get some more information from some of you of what you have presented today. I told Carl when he asked me some time ago that I would not have time to prepare a presentation, unfortunately, because this is a very busy time for us. But then on the other hand, we don't have much rock in Denmark, so it's I couldn't say too much about the rock part of this. So instead, I've read the report and looked at, and I would like to make some comments on that, and also maybe give some information, and you can ask me about how we do things, because I wasn't really sure of what, if I was going to make a presentation, what actually to present. In relation to the last presentation by Gudny, I can say that we have been doing a demonstration site on the use of incinerator bottom ash as subbase for 17 years. And we followed 5 different, you could call them lysimeters. They were each 100, or 4 of them was 100 square meters, and the last one was 200 square meters, and that was actually a parking lot. So it was paved with asphalt, and we followed the leachate from there, and we followed the infiltration, rate of infiltration. And it was actually, we got a little surprised about the infiltration at the parking lot, because it started around 4% of the rate of the annual infiltration, but at the end it was about between 13 and 14% there, and maybe it was used all the time for parking, and maybe it was not the best asphalt, but all the sites were made exactly as you would do in road construction. The others were, well, one was covered by flagstones, and the other three were covered by pebbles in order to maximize the rate of infiltration, because we were interested in getting as high as possible in the LS ratio, which by the way ended about 2 to 3 in most of the sites, but only about 1, a little more than 1 in the under the pavement over 17 years. But that's.
Sorry, but do you have published, or is there any reports?
Yeah,
that's a
sensible area, because I'm working on the report.
Okay,
it ended in 2019, and I'm still trying to finalize it. And I was hoping to do it by the end of this year. We got so much work during the last few months that I'm a little doubtful that I will succeed, but then maybe in the beginning of next year. And there is, I have a presentation from about a year ago that maybe I can share with you, which gives you some of the main results. But anyway.
A question of clarification. You mentioned 4% initially and 13 to 14%. Was it percent of the precipitation, or was it some kind of net precipitation?
It was the precipitation. It was actually the what do you call it? The precipitation recalculated to standard conditions. Okay. Which is not exactly what you measure.
Okay.
But it's pretty close. And we can, well, both, we calculated both. So there was about maybe 1% difference between.
Okay.
That's fine. And the maximum participation with the pebbles, how much was that? Was it good news?
Sorry?
The maximum infiltration with pebbles.
Well, that amounted to up to 2 to 3. I'm not exactly sure, but well, I won't waste time to look it up. But that amounted to an LS value of 2 to 3 at the most.
Got it.
And that you can relate to a layer of bottom mass of 50 centimeters. So you can calculate the amount of water from that if you use a density of maybe compacted density of maybe 1.8 or so, something like that.
Got it.
Okay, also Timo mentioned this test method that was used 10 years ago, 1744-3. I hope you're not using it anymore. It was developed by TC154 on aggregates, the Cent TC, but it was I've been working in 10C Cent TC 292 and 444 exclusively with leaching, and also is TC 351, which made the test for the products, where we used the test developed for waste as a starting point, and the one that you showed, Gudni, that was actually published the the latest, or the first correct version was published in Denmark in this week, actually. I think in other countries maybe in September, but so they are finished now, all 3 of them.
Thanks. Yeah, good.
But we advise TC 154 against this TC or 1744-3 because it mixes both equilibrium and diffusion, and you don't know which. It's a mixture, and you don't know what mixture. So therefore, you don't get really reliable information from that test. But that was a digression. I made some notes about the test you have used there, 12457-2, which is from TC 292.
Yeah.
And there was one thing that worried me because it said that it was you sift the material and use the material below 4 millimeters.
Yeah, it's crushed until 0 to 4, correct. That is the method, isn't it?
The method is yes, 4, but then it looks as if you have discarded material larger than 4 millimeters and not included that. Is that
no? So our test in the study was done by ALS. So they did it according to standard. They told me anyway. So that.
Oh, okay.
And I probably miswrote in the report then. Sorry.
Okay. That's because if you do that, you have different minerals.
Yes.
Have different hardnesses, and that would make a big bias to the testing. But
that's interesting.
That's good.
Because we have Anna here today from Skanska, and she pointed that out to me just a few weeks ago. The importance of measuring the right stones, not just the size, but actually the ones that we want to measure, the whole stone. And also, of course, great.
And that's crushing it is, of course, to go as close to local or equilibrium as possible. Yeah. Because the interpretation of the test is actually based on the fact that you reach low equilibrium, and in the column test, local equilibrium. By the way, I didn't see any results of the column tests in the report.
Oh yes, they are. They are there. They are just following the first batch test and then column test. So each are after each other. They're pretty closely, but Mark noticed a few differences, especially when it came to was the first flush LS2 to LS10. Then there was a larger difference, correct, Mark, between the two.
Yes, but did you not analyze all 7 fractions?
Sorry, no. One more time.
The column test, in the column test, if you do it as it's
no,
as a standard.
We did a cheap one. We just did LS2 and LS10.
Okay. Okay, because if you want to use it to make material specific kappa values, you need, and particularly in the beginning, you need all the points on that curve.
But you also had 0.2, I think. So it was
three points. Yeah, 3 points. But we did
still
7.
Sorry.
Since most, and I think that was noted by one of you, that the most action is in the beginning.
Yeah.
So therefore, it's good to have both at least 0.2 and 0.5 and then 1 and 2.
Important.
But okay, so you might have to do that if you want to make more specific kappa values. I was also thinking it would be very nice, and I'm sure you have it. It's just not in the report, the pH value, because that should always, whenever you do a leaching or report a leaching test, there should be capital punishment for not reporting pH.
I will blow my head off after this meeting. We do have it. And
it's
yes,
very important
yeah,
because if you want to assess the results, I don't know how different they would be, because my experience with rock is quite limited. But it would be interesting to see that.
Yep.
And also it was mentioned somewhere, and that you have a lot of nitrate in there because of the
blast
of the dynamite.
right, yes.
And that's probably, I've also met that I've also done some work on the mining waste directive, and there it was also mentioned that it's something you have to look at, and you may probably have some limit values for that as well.
Correct.
So it would be. I was just wondering why you did not include nitrate.
Oh, we did. They are on page number 29.
Results.
So we have it. We have a certain section about the reuse of what call it in excess rock materials in Stockholm. The rocks from the what's called subway tunnels, from the tunnel rocks. So we have a nitrate and in there, and you can see an increase of 143%. Compared to usual rocks, so there is a difference in nitrate.
Okay. I'll have to look better. It's next time.
It's by no means a perfect report. We are just starting to stumble across the floor here.
And well, then you skip barium in some of the later.
Barium? No, barium is included.
In risk. Well, I saw somewhere it was mentioned with risk assessment. Maybe it was one of the risk assessment papers that barium was not there, because I could guess that would give you some anguish, because it's when you look at crushed concrete, for example, it's and compare it to limit values for the recipients, it's definitely something that needs to be discussed somehow. I'm not sure that the limit values are not too low, but it's definitely something that I would think, even if you look at virgin material like gravel, you get high leaching of barium, and so it must be part of nature as well.
True.
And by the way, speaking of virgin material, I think that the approach they have used in the Netherlands, that you have to judge virgin material in the same way as you judge recycled materials, because an effect does not get less just because it's natural.
No.
And that might have some influence also on the
of course,
the limit values that you will set in water bodies. I also noted that you looked at KD values as to calculate source terms from the solid phase,
Yeah.
I would doubt that. And again, I don't know how different the different rock materials are, but I would think that they would be a little different, some of them in mineral composition.
Yes.
And it's the minerals that control the leachability of various substances.
Yeah.
So therefore, I think it would be very difficult to make general KD values in that way to use for. I'm all for using KD values in the transport phase, but that would be for soil, not for rock materials, I think.
Makes sense.
Yes, there are some mistakes, but we can take them.
Don't embarrass me too harshly.
Yeah, you made me spokesperson for the technical committee,
Exactly.
and I think that's overdoing it a little bit. I was part of it, and but I was heading a consortium that did the robustness testing for this. But I think somebody might read it and think, oh,
got it. I will adjust that. Yeah.
So I'll and there's also on the same page in the first paragraph, you are referring to a monolith test 15864. That one has been cancelled because it was not really useful, and the correct number is 15863, so it's not far from right. But it's that's the one you would want to use, and that's the one that was the starting point for the 16637-2.
Got it. The new one. Yep.
Yeah. And then if I really think that this is a great enterprise, or what you would call it, that you have started here, and it's a very good way to get a material accepted or not accepted, if that's the case. But you have to do it yourself. You cannot. I think it would take too long if Naturvårdsverket should do it for you. So I think that's a very good initiative, and I think I think you also talk about, and I think it's in here, but it was also in one or two of the presentations, that you would not only look at the service life, but also or at the total life cycle.
Yeah.
What happens when its useful life is over, end of life, because then it can be, depending on, and I don't think with this material you would probably not make records of where it was used, central records of that. So it can be spread anywhere after that, and in that case, you would like to know the sensibility to pH changes.
Yes.
So I think this would be really complete if you did that. If you did, not on all of them, because it's a bit expensive to do that test, because it includes analyzing eight fractions.
Yeah, got it. The whole column test. Yeah.
But you could perhaps find, and you have also started that in trying to make some types of material or types of rock material in this diagram on page 39. So you could probably make some, find 3 or 4, maybe 5 typical types, and then do the pH stat test for pH dependence test for those.
Yeah.
And that would be it would be good to have that. I think when after some time you have to go to the authorities and tell them what
Sure.
you got,
Yes.
and ask them to accept that.
Exactly.
And have you considered at all to invite them to
Oh yes,
this
they have.
point?
They have invited to every step of the way, but they are very shy. They don't
Yeah,
want
yeah.
to. They don't want to tell us things, because then we could possibly use that against
You
them.
could use them as hostages.
Exactly.
I
They're
suppose.
afraid of being hostage taken.
So
That's correct.
I always try to take hostages when doing
Exactly.
things like
Yeah.
this,
Mm.
so, and ask them, what do you think that would be necessary
Mm.
altogether,
Mm.
and then discuss it. And because then, but they're not ready for that, and so it would be difficult. But in any case, then you should probably ask yourself, and I'm sure you've done that, what would they come up with? And I'm sure they would come up with a life cycle analysis, or
That's for sure. That's for
life
sure.
cycle not analysis maybe, but considerations that cover the entire life cycle.
That's
So
true.
so I would think it would be prudent to maybe look at pH dependence, and it might be just straight horizontal lines, and that would be.
Yeah.
But
That's what we found so far, for the leaching levels. So that's why we didn't see it.
Yeah. Okay.
But
Okay.
you're right. We could do maybe a few tests just to confirm that. Mark, you had a question or maybe an announcement, please. Microphone, please.
Yeah, that you mentioned that barium had a very low limits. In my opinion, barium is very difficult to risk assess, because there is not very much either toxicological or ecotoxicological values. But and I'm curious, what limit are you referring to for barium?
I'm not sure. I should have looked it up. But I remember we had a big discussion when we did the concrete that you have referred to, the concrete.
Okay, maybe it's in that report then, so I can see.
And
oh, you.
So you see, I had this question actually for UC, I think a year ago, about barium, because when we compare the end of waste criteria for concrete, compare that to Mara in Finland, there are differences when it comes to barium. Can you compare? Can you comment on that, UC? And do you have any opinions about barium, or how we should look at that?
Sorry, I was unmuted. I have to say that, as I mentioned, I haven't really been thinking about this stuff for some years now. So, but I do remember that for example, reference values that we've been using with respect to this regulation, for example, the reference values of barium, they've been actually pretty high.
Got it.
So the drinking water criteria in general, they are rather high, but then there are of course certain kind of barium complexes or how do you call them, some barium forms of barium that kind of might be an issue. But we had some discussions about it, but I don't really remember what the conclusion was. Please.
Sorry, go ahead.
No. I'm happy to hear.
I may be mistaken there, because the groundwater criteria are high, but they're 700 micrograms per liter, so and that's very high. But it might, and I might remember wrongly. But we have looked also at different surface water criteria, and I think some of them were low, but but I may be mistaken, remember wrongly, and then I apologize for that.
No problem.
But I'll look it up after
Yeah.
this and send you a message. Okay.
Yeah.
Where were we? Boom, boom. Yes, just a comment. Okay, that was the pH
Yep,
dependence.
pH, yes.
And also and I think that was actually mentioned also that when you construct the scenarios and put some heights and some different conditions in there, those conditions should also be part of the conditions of use eventually. And if you look at this report is called ender waste, but it's not necessarily a lot of ender waste there, but of course, well, the criteria should be the same in the waste criteria. But if you look at the 4 or 5 conditions in article, is it Article 4? In the waste framework directive, one of them is that you should set conditions for use.
Yes.
It's not written directly in the bullet points, but it's written before that. So maybe it's easy to forget it, but that's actually important.
Yes.
It didn't happen in when we did the waste acceptance criteria for landfilling, and we did our also calculations that were a little more strict, but using the same method in Denmark. But some of the conditions there were actually forgotten when the statutory order was written. So that's sometimes a problem, because it gives expectations that cannot be met, and you could see that from the conditions upon which the calculations were depending. Okay,
that was, yes, the direct ender waste criteria for Europe and Sweden and Norway. I haven't included Denmark here, but I think we are have the same
we have just a translation of the
exactly. That's what we have as well.
The directive. And here yes, these are the bullet points, but maybe not.
Sorry for
maybe not the thing that you should set conditions for use, which is not a bullet point.
Got it. Cool. I will leave.
But anyway, I could also warn you or tell you what they've done in Denmark. Yes. We don't have any guidelines on how to meet this, because in Denmark they have outsourced the responsibility for waste classification to the 98 municipalities.
Oh,
which is really stupid.
Yeah, that sounds stupid.
Because there you have 98 municipalities, and in each of these, or in most of these, you cannot have a whole person just occupied with waste classification. No. And this is both classification as hazardous or non-hazardous, and getting end of waste status, and consider the what happens if you have one municipality that gives a certain type of waste in the waste status, and another municipality says no, we don't, we won't classify that as in the waste. That's a total chaos, in theory at least. But fortunately, and I've been mentioned every opportunity I have had during the last 5 or 6 years. I've said this to the Danish EPA. Why don't you centralize this? Because then you could have a group of people that specialize with this, and you could advise the municipalities if they had to deal with it. So from 2025, this will actually happen. It will become centralized. So there are also some good news every now and then.
That's great. Thank you, Ulle, for your input and your perspective. I would love to have call you later if it's possible to just try to improve the report that we wrote last year, because it's important that we move forward. And of course, I learn over time as well, speaking to people like you.
It's a great initiative.
So Mark and Timo and Gudni and Jussi. Yes, Gudni, please comment on each other. That's the point of the idea.
Yeah. I have a question or maybe something to think about, because when I saw the values from Mark, it's kind of in the same level as the inert waste landfill criteria. And how do we communicate this? Why is it okay to use these products or materials? When it's a waste, you have to put it at the inert waste landfill with all the requirements that you have. And I know from the Norwegian environmental authorities that they are very critical if you have these high levels. So I'm surprised that in Finland that they have made it through the environmental authorities there. So it's interesting, because I think if you are a person who is not kind of into this, it's not easy to communicate that. Why can you use it for a road construction if it's not a waste, and or if you have to put it at a landfill? So I don't know if you have any comments on that.
Well, one comment would be, of course, that the requirements for an inert landfill is, of course, not very strict. If you talk about an inert landfill, and it's I guess the limits should not be seen as a requirement to put something on that landfill, but more the possibility to put something on the landfill if you want to get used of it. But of course, you need to kind of relate your values to all other values, and I mean, like in the Finnish case, that if you start having values which would exceed these values for non-hazardous landfill, you would be a little bit problematic, I would say. But I'm not sure that exceeding the inert values is really such a big problem, because it's still, at least in some of these cases, it's rather protected by covers, etc.
Do you have the same system in Norway? So inert, non-hazardous and hazardous landfills?
Yeah, and the same criteria.
Okay.
So it's the same as in Europe.
I can say that in Denmark, nobody uses the inert waste landfills, because if they can comply with those, they can be used in different, utilized or recycled in most cases anyway.
That's very good way of doing it, I would say. Don't need them anymore. And you see,
Yep.
do you have any?
Well, maybe I kind of agree with both Mark and Ole said. And on the other hand, if you think about the definition of inert, it kind of implies that it's inert. So
exactly, yeah. No,
and but I guess like what Mark already said, that it's well, first of all, also those waste acceptance criteria have different kind of methodological basis, and it doesn't mean, of course, that they reflect the acceptable concentrations of leaching at each stage. And once again, it doesn't mean that it's simply the fact that you have to classify the disposal sites in a certain manner. So I don't see, but that's why, on the other hand, as Mark also referred to that I mentioned that we made this kind of a political decision to set an upper limit, but the upper limit was the non-hazardous waste landfill criteria, just due to the fact that it might feel a bit strange that, okay, this is a kind of material, even those criteria, exceeding those criteria, it doesn't mean that they would cause environmental or health risk at all sites. By no means it doesn't mean that, but from the political viewpoint, that might seem a bit strange that, okay, you have a material that you couldn't dispose on a normal landfill, you'd have to take it basically to the hazardous waste landfill, but okay, it's okay to be used on the road construction or whatever. So that's kind of, I think, if you think about this criteria from the political perspective and the how the perception of people, I think those higher landfill criteria are the one to look at, I would say.
Yeah, great. And Mark, do you have any feedback to the other presentations and what we can learn from?
Yes, I have some questions and some things to discuss. And one question was for Jussi here. As I understand it, you calculate the C0, the kind of initial concentration, and from that you back calculate what that corresponds to regarding the leaching at LS10. Is that correct?
Yes, due to the fact that we were using this kind of these analytical solutions and the Excel-based model, you need to have first the kind of at the first stage we kind of because in our case we wanted to kind of make sure that, okay, can we safely increase the old values? That was the basic questions, because especially for the acids, they couldn't be used due to the values were so low. On the other hand, the new values are also quite low, so they really can't be used as such, hopefully for the stabilization later on. But so you first have to kind of put a leaching value there in order to do the first round of calculation, and then you'll get the first kind of the attenuation dilution factors. So we, for example, started the calculation by using the old Mara decree values, so the inert waste landfill acceptance criteria values, to calculate the firstly the zero the C0 concentration at the source, and then kind of you got the attenuation factors, then you went forward, and then at the last stage you kind of came up with the leaching value that corresponds the reference values in groundwater. And then I also mentioned that we needed to do, due to these constraints in these analytical solutions and the Excel, you needed to do this kind of an iteration phase due to the fact that this decrease in source was sort of described in a way that you couldn't do it directly.
But because my experience, because basically this MRR model, which I showed results from, does the same, that you basically estimate your C0 and then you back calculate using this kappa value. And what I've seen is that it's not a simple relationship between what kappa value gives the maximum LS10 value. So it can be a peak somewhere in the kappa. It might not be the lowest. It's sometimes the highest, but sometimes it's the value in the middle. It depends on the substance and on the scenario. So my question is, did you try to really evaluate the kind of attenuation factors from different types of materials, or did you just use these standard values from 1996 or something?
We use the standard values basically not from 96, but because they have been updated at I don't remember the year, but at least, well, some of the values might be the old values, but somehow updated. But due to the fact that because we had quite a lot of waste materials being included in the decree, quite a lot of contaminants that we wanted to evaluate, and all that stuff made it, well, let's say it would have been impossible with the resources that we had to do it really properly for everyone. So we are by no means, we have written it down that we by no means try to claim that our values reflect the reality at every case. By no means, that's not it. But we just wanted to make it in a systematic way, so we had to make lots and lots of assumptions. But on the other hand, I think there's some of the issues might not be the most conservative, let's say, regarding the parameters and the assumptions we made. On the other hand, there are quite a lot of conservativeness built in the system anyway. So then we more or less kind of evaluated that we hope and trust that the final outcome is conservative enough, at least, let's say. And regarding these previous values, they are rather close to them. Of course, some of them have increased quite a lot, but nevertheless, we haven't had issues. We try to kind of look for data from actual monitoring efforts, groundwater, surface water, whatever, that have they been like actual issues with the previous values. And we didn't get that. The feedback was that no one at least had known about it. Of course, it might be that there's not enough monitoring in the proximity of these reuse sites, but nevertheless, so, and we still basically haven't received any information that they would be like too high, let's say, but they are not reflecting reality, and we are not saying it. Yeah, and that, surely different kappa values for different materials, that would be perfect, but we didn't have a possibility really to even try to do that. So yeah.
Thank you, Jussi. I think that will be the last thing we say today, and we will, of course, continue this discussion maybe within this project or maybe outside this project. But I think it's really important, and of course, it might be that we send you a few questions, Jussi and Timo, as well, and to Gudni and Ole just had to leave as well, and. Thanks a lot, Mark, for your presentation, Jussi, Timo, and all the others who have been listening in. And let's continue discussion in other ways. Thank you.
Yeah. Okay.
Bye.
Thank
you so much. Bye-bye.
Thank you. Bye.